Just from your computer, open the STM32CubeIDE, go to File, New STM project, will initialize the STM target selector. Type here STM32F, select STM32F401RE, show here selection. After that, select the first one, and because original board, select here Nucleo F1RE. After selection, you can see here the board, it is this. See here specification, go to the next. It will ask you the project name. Right here, give the name Nucleo Servo Port Plane. Then you can write want the STM32F401RE. So one thing you remember, you cannot put here the space, put the underscore, then finish. It will ask initialize all parameters. Default mode, tell yes. So now you can see here, this is the default mode of STM32F401. Okay, this is already set some pins, but I will show you how to set your own pins, because when you are using the blue pill or black pill, you will not find like this, because that is not the original. Just I am clearing the pins. Now what you have to set, go to the left side, pinout configuration, go to sys. Here RC is there, you can see some setting. Here debugging is disabled, select serial wire, only this setting is required here. Then go to the analog and the timer, this two more sets. Go to the analog. The analog, I need to set one pin for ATC for potentiometer output 5. So I will select here PC5. So just type here, you can see PC5 is blink. Now select PC5 and it is telling you it is on ATC1 IN50. So PC5, just select from here, it is selected and color is changed. But if you go here in ATC1 mode, you can see automatically it is selected. Deselect, so this will also go, but here once we are selected, that's why it is yellow. Okay, deselect from here and select from here. Also you can see, no, it is again select. Now we need to set the timer. So in the timer, we need to set the internal clock. Later on in details, I will show you why I am setting 15. If you go to PA15 and select, it is showing here timer 2 channel. But the magic is when select the timer 2 and channel 1 as a PWM generation channel, it is coming to timer 2 channel 1 on EA0, that is wake up pin. But we want to use EA5. Just go here, you see the magic. When I select here, automatically it will change from here to here. So I will select here timer 2 channel 1. You can see here this automatically disappear and PA15 is select. So this is, I am shifting the pins available in the STM32. Now we'll go to ATC setting, go to the ATC and IN15 already selected here. Go to the parameter set. Here what we need to check, IN15 already selected. See, it is already showing here 12-bit, okay. Then resolution 12-bit, okay, correct. Sampling time we need, where is the sampling time? Go to the rank 1, expand this one. Here you can get the sampling time. It is showing here 3. We'll fix here, set to 56 sampling time. Here sampling time. Why 56? I will show you. Give complete action. Now go to the timer. Then timer channel 1 already selected. In parameter set prescaler we need. So I will set here prescaler to 83. Why 83? That is also a reason. I will explain you later. Then here counter period mode auto, that we will set 199. Okay. Why it is set here? That also I will explain. Then here auto reload, preload, timer event, output fast. Okay, in the parameter setting, then PWM generation channel 1, mode 1, then pulse. Here we set the pulse 1500. 1500 means servo center point is 90 degree. That's why 50. No, other one is prescaler. If we set 83 and this one triple line is 1 megahertz clock with nearly 20,000 center gives 20 millisecond period. Just what a servo like. So servo works good on 20 millisecond per period, and the pulse which we set 1500, that I already told you, servo center point pulse width between 500 2500 microsecond. Control the servo from 0 to 180. So at 1500 the 9 center point, and from 500 to 2500 microsecond will control the servo from 0 to 180. That's why pulse is here 1005. One thing more, in the ADC here you select the continuous conversion enable. Next is go to the file, save. Do you want to generate code? Set yes. This action can be associated with C++ perspective. Do you want? Yes. Then it will open the main dot. And what was the our project was here top Nucleo servo port explain this project. Go here, go src same file. So in the top here include main.h, no need to change. First line of code will add here. Go to the private user code. User code begins 0. Enter here. I will paste here and I will explain what is the code. The first line void SetServoAngle unsigned 8 angle. This is a function declaration or definition header in C language. Means the function does not return any value. SetServoAngle, the name of the function, is just a label you call a function later in the code. Now this line of code, what it means, this function take an angle between 0 to 180 degree, convert it corresponding PWM pulse, send that pulse to the servo motor using a time code. This one is unsigned int 8, and this is the function header. You want to details unsigned int underscore. This means the function will return 8-bit unsigned 0.5, and here it will return between 0 to 180 responding to the servo angle. ReadPotentiometer means the function name, then void, the function takes no input parameter. Next is start it here, hall it start. This tell it STM32 ADC analog to digital converter to start reading the analog value, and H81 in the ADC handle configure earlier in CubeMX, for example reading from pin. Then next is hall ADC pool for conversion, means wait for the conversion to complete. This function waits pools until the ADC finishes conversion the analog signal to a digital number. Means 100 is the timeout in the millisecond. If ADC doesn't finish in that time, it gives up, but we give here some other reading. Next is unsigned int ADC value. This means get the conversion digital value, read the digital results from. Since the STM32 is actually usually 12 bit, the value between 0 volt means 4095 equal to 3.3 volt is the value is 3. Is volt reference is 0 to 3.3 volt. Then next is hall ADC stop the save power and pair for the next. Then next is return ADC value 1804095. The potentiometer gives the voltage between 0 to 3.3 volt. ADC converts that to 0 to 4095. This line map the 0 to 4095 range into 0 to 1, means 0 equal to 0 degree, 20484 equal to 90 degree, and 4095. Since the function return type unsigned 8, it automatically fit in 0 to 180 degree. Next line of code I will write here user code begin. Also I will write in the option so you can use it for your code. This is like this: hall team PWM start and STM2 team channel 1. So what is the meaning of first this line hall team PWM start? This means this command start PWM generation on timer 2 channel 1. STM2 is the handle for timer 2 created automatically by the CubeMX. Team channel 1 means you are using the channel 1, often connect to the pin A15. Our setup: the servo motor receive the PWM signal pulse between 0.5 millisecond 0.5 millisecond. Without this line the servo won't move because the no PWM signal is sent. The next, these settings are set servo angle 0, hall delay 1000, means move servo to 0 position, hall delay 1000, wait for 1 second or 100 millisecond, then same move to 90 degree, 80 degree, and the finally return servo back to the center, wait for 1 second. This is only for the test function. So what happened physically when your code runs? PWM signal start on PF. Timer 2 channel 1. Servo receive pulse corresponding to 0 and 180 degree. You will see the servo moves left, center, right, then center, pausing 1 second each step. The next line of code will write here in while 1. I will type here. Then I will explain what is this. This is the main loop code. What is this meaning? This line calls your custom read potentiometer that start it reads analog voltage from convert to number 245, then map that to an angle value from 0. The result is stored in a variable angle of type unsigned 8_8 bit. What is this mean? SetServoAngle means this send the angle value. Initially SetServo convert a number from 180 to a PWM pulse width like 500 microsecond. That PWM control the precision. So if you rotate the potential knob, your servo real time acting, turning the knob, ADC change, PWM pulse change, and finally go here to the project here. Filter that connect US port, go to run, bugger, error, and your servo is moved 0 and after that whenever you move. Hi everyone, welcome back to MKRC lab, this place where experiment something works and sometime teach us a lesson. Today we are controlling a servo motor using a potentiometer with STM32 and CubeIDE, and yes, it is finally worked this time. So grab your Nucleo board. Let's dive in and see how to make a servo dance like this. We'll connect three main things: a servo motor, a potentiometer, STM32 Nucleo board. We'll connect the signal line. Here I can show you the signal line. Actually wires I will disconnect. No, you can see easily. So where is our signal line? So these three wires coming from servo motor. Okay, first one is brown line, which is connected here to the ground on the Nucleo board, and the second one is red line, which is connected here 5 volt on the Nucleo board, you can see here, and the third one is the orange line, sometimes it is yellow, and where it is connected here, you can see board, this pin. You can count this pin 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th pin. I will show you in the picture. 9th pin is connected with timer 2 channel 1. Now you can see the potentiometer, 3 cables. This is our potentiometer and this is 10k ohm. First I connect here 3.3 volt. Okay, you can see from the Nucleo board. Then I connect the 5 ground pin. You can see it is connected here ground. Then the center pin, which is on the potentiometer center pin. Then the signal line is the third line 1, 2, 3, which is coming from potentiometer center 1. It will go to PC5, that is ADC1 IN15. So this is our connections. Now one more thing, I connect this full system after flashing the code 5 volt supply from the power bank. I connect here, which is called win pin. You can see here win pin, that is for the external power supply. Okay, when you do the power from the external source, first is win pin, second is ground pin. To the ground you have to connect, then board light is up. But one more thing you need to change. You can see here no light in the board, but light is here from the ST-Link programmer. If I connect this pin here, what is happening? Still there is no power to the board. It is actual original settings. This means if we connect the power from the USB source, then it will come. But now it is connected from the win pin, so we need to change the jumper. Now you can see here this light is on, this light also on, and this light LD2 LD1 also on, and this LD3 on the board also on. This means it is connected through the power supply. Even it is connected from here or from here, it will light up, but you need to change the jumper. This is original setting for this one. It is called E5 volt, U5 volt. U5 volt means user from the here, E5 volt from here, that is external. When it is connected, then you can move your potentiometer. So it is connected from here. Okay, I will change the jumper to the original setting. Also I will remove the ground and the win pin which is going to the 5 volt. So now there is no power from the external power. I will connect with the PC. Now it is connected from the computer. So now 5 volt is coming from the U5 volt. This is the dance. Okay, PC5 is our ADC pin that analog to digital converter. It read the voltage for the potentiometer. PC5 is our ADC pin that analog to digital converter. It read voltage from the potentiometer.